3.5 billion people will eat this one food today. Every one of them, every single day. It provides a fifth of all the calories the human race consumes. Growing it swallows a staggering share of the fresh water we divert for farming, and the flooded fields it grows in are one of agriculture's larger sources of methane. It is the most consequential food on the planet, and most of the world outside Asia barely thinks about it. This is rice. So how did a single grass end up ruling half the human race? The answer starts 10,000 years ago on the banks of one Chinese river. In the Yangtze Valley of what is now central China, a wild grass was pulled into cultivation for the first time. And the traces left behind by the Shangshan culture are still the earliest evidence of rice farming found anywhere on Earth, roughly contemporary with wheat in the Fertile Crescent and maize in the Americas. But rice did something those grains never did. It split in two. Japonica, short, sticky, built for cooler climates. And indica, long, dry, built for the tropics. One grass, two grains, and two entirely different worlds about to grow out of them. Today, around 90% of the world's rice is grown and eaten in Asia. Global production runs to more than 500 million tons of milled rice each year, over 700 million tons when counted as unmilled paddy. The contrast in how much people eat is enormous. In the United States, the average person eats about 25 pounds of rice a year. In the biggest rice-eating nations, Bangladesh, Vietnam, Myanmar, it is well over 300 pounds per person. There, rice is not a side dish. It is the fixed center the rest of the meal is arranged around. Nowhere is that clearer than in language. In Japanese, the everyday word for a meal is gohan. It also simply means cooked rice. Not food in general. Not eating. Rice. At a traditional Japanese table, the rice sits at the literal center, and everything else, the fish, the vegetables, the soup, is okazu, side dishes, there to accompany the rice. When a culture's word for a meal is also its word for a single grain, that grain has become something more than nutrition. It has become identity. Simply bows over his own small bowl before taking a bite. Rice did not only feed power. In much of Asia, rice was power, the literal currency of the state. In feudal Japan, wealth was measured not in coins, but in koku. One koku was the amount of rice thought to feed a person for a year, about 150 kilograms. A lord's rank was set by how much rice his land produced. To count as a daimyo, a great lord, your domain had to yield at least 10,000 koku, and samurai were paid their salaries directly in rice. To measure a man's standing, you measured his grain. Our own simply would happily take his wages that way. And rice reshaped the land itself. To move it from the fertile south to the hungry capitals of the north, China dug the Grand Canal, the longest artificial waterway on Earth, over 1,000 miles of it, built in large part to carry grain. About 1,000 years ago, a fast-ripening rice from the Kingdom of Champa, in what is now Vietnam, reached China. It ripened in 60 days instead of 150, letting farmers harvest twice a year where they once harvested once. The food supply surged, and China became the first nation on Earth to pass 100 million people. Rice did not just feed China, it multiplied it. The rice you buy decides the rice you eat, and the sharpest divide is between brown and white. Brown rice is the whole grain, the bran and germs still intact, only the tough outer husk removed. White rice is milled further, stripping the bran and germ away and leaving just the starchy center. The difference in fiber is large. Brown rice has about 1.8 grams per 100 grams, white rice about 0.4, roughly 4.5 times less. And on the glycemic index, white rice runs from the mid-60s into the low 70s, while brown rice sits around 50 to 55. For most of its 10,000-year history, rice was eaten brown. Then, in the 19th and early 20th centuries, machines to mass polish it white spread across Asia, and a disease followed them. Beriberi, caused by a deficiency of thiamine, vitamin B1. The cause was hiding in plain sight. The bran that milling scraped away was exactly where the thiamine had been. The modern fix is fortification, spraying synthetic B vitamins back onto the stripped grain and labeling it enriched. It works. But look at the shape of it. Take the nutrients out for shelf life and appearance, then sell a synthetic version back as a feature. By the middle of the 20th century, Asia was on the edge of mass famine, its population climbing faster than its rice could keep up. The answer came from a research institute in the Philippines. In 1966, it released a new variety called IR8, a short, stiff-stalked rice that could carry a far heavier head of grain without toppling over. It roughly doubled, and in places tripled, yields, from 1 or 2 tons per hectare to 4 or 5. The press called it miracle rice. It is one of the main reasons the mass famines predicted for Asia never arrived. But feeding billions this way has a cost, and the first part of it is water. Rice farming uses close to 40% of all the fresh water diverted for irrigation on the planet, the single largest agricultural claim on it. The traditional method, flooding the paddies, takes somewhere between 1,000 and 2,000 liters of water to produce a single kilogram of rice. The flooding is not ignorance. Standing water suppresses weeds, steadies soil temperature, and recreates the wetland the plant evolved in. It worked for 10,000 years. The problem is that 10,000 years ago, there were not 8 billion of us. The second cost rises out of that same flooded field as gas. Cut off from oxygen, the microbes in waterlogged paddy soil break down organic matter along a pathway that releases methane, a greenhouse gas far more potent ton for ton than carbon dioxide. Worldwide, rice paddies produce roughly 1/10 of all the greenhouse gas that farming emits and around 1/8 of the methane humans release into the air. There is a fix. Alternate wetting and drying, letting the field drain now and then instead of sitting permanently flooded, cuts those methane emissions by 30 to 60% with little loss of yield. Adoption has been slow. The flooding does one more thing, quietly. Rice takes up arsenic from soil and water far more readily than other grains. And because a flooded paddy is starved of oxygen, it releases more of the soil's natural arsenic into a form the plant can absorb. That is why rice carries more inorganic arsenic than almost any other staple food. The reassuring part is that preparation matters. Cooking rice in plenty of extra water and draining it off the way you cook pasta can wash away 40 to 60% of that inorganic arsenic before it ever reaches your plate. Rice did not only feed Asia, it may have helped shape how Asia thinks. A flooded paddy takes about twice the labor of a wheat field, and the water has to be shared and timed across many farms at once. You cannot flood your plot alone. In 2014, a study in the journal Science argued that this deep history of forced cooperation left a psychological mark. People from rice-growing regions tested as more collectivist, more interdependent than people from wheat-growing ones. A follow-up a decade later on farmers quasi-randomly assigned to grow rice or wheat pointed the same way, which brings us to the fight over rice and blood sugar. White rice has a glycemic index in the 60s to low 70s, high enough that it is routinely blamed for driving diabetes. The real picture is stranger. Japan, South Korea, and Taiwan eat white rice at nearly every meal and post some of the lowest diabetes rates in the developed world. The number on the chart misses the context. Rice eaten with fish, vegetables, and soup digests far more slowly than rice eaten alone. And if you cook it, chill it overnight, then reheat it, part of its starch turns resistant, lowering the glycemic response by another 10 to 15%. So here is rice, whole. 3.5 billion people. 1/5 of the world's calories. 10,000 years of history. Close to 40% of the world's irrigation water, roughly 1/10 of farming's greenhouse gas, and most of its nutrition quietly milled away the moment the bran comes off. It fed empires, averted famines, and may even have shaped a way of thinking, and how we grow it and eat it, from brown versus white to flooded versus drained, is still anything but settled. It is the most consequential food on earth, and it deserves far more attention than a side dish. Rice is infrastructure. It built civilizations, and it still feeds half the planet every day. Next time, something far smaller and far stranger, the only food on Earth that never spoils. In 1922, archaeologists opened a tomb sealed for more than 3,000 years. And among the gold, they found pots of honey, still soft, still golden, still edible. No preservatives, no refrigeration. It had preserved itself. How a simple, sweet liquid cheats time comes down to dry sugar, hidden acid, and a weapon the bee builds into every drop. Next time, honey.